In this video, I will explain how to find the domain of a rational function. So I have three examples for us to work through here. Let's take a look at the first example. We have f of x equals 7 divided by 4x minus 2. So we're basically asking ourselves, what numbers can we plug into x where we'll get some result for f of x, as long as it's not undefined? Well, for this particular example, this equation would be undefined if the denominator is equal to 0. So what we can do to figure out the domain of this function is we can say 4x minus 2 may not be equal to 0. And then we can just solve for x. So if we add a 2 to both sides, we'll get 4x is equal to 2. Now to get x all by itself, we can divide by 4. Divided by 4. X is equal to 2 over 4, which we can reduce to 1/2. Excuse me, that should say not equal and not equal. So for this particular example, the domain of x, or what x is allowed to be, is all real numbers that are not equal to 1/2. So if we wanted to write that in interval notation, which sometimes you might be asked to do that, you can write negative infinity up to 1/2 union with 1/2 to positive infinity. And what that's really saying is x is allowed to be any number that ranges from negative infinity up to 1/2, but not including 1/2, along with, not including 1/2, any number up to positive infinity. So that would be the domain of this particular function. All right, let's take a look at this next example. We have f of x is equal to 5 of x divided by 6x squared plus 4x. So we have a similar situation. The only way that this function will be undefined is if this denominator is equal to 0. So let's go ahead and say 6x squared plus 4x is not allowed to be equal to 0. And then we can just solve for x to figure out what x is. So if we look at these two terms, we can say the greatest common factor between them would be a 2x. So we can pull out a 2x, which leaves us with 3x plus 2. And we can say that may not be equal to 0. Now what we can do is we can set each of these individual terms. So 2x is not allowed to be equal to 0, and 3x plus 2 may not be equal to 0. So in this first example right here, 2x is not equal to 0. X is going to be equal to, x may not be equal to 0. Because when x is equal to 0, 0 times 2, that's equal to 0. So now on this one, x, to solve for x, we can say subtract 2 on each side. So we've got 3x is equal to negative 2, and then we'll divide each side by 3. So x is negative 2/3. So in this particular example, x can be all real numbers except for 0 and negative 2/3. Because when x is equal to 0 or when x is equal to negative 2/3, this denominator becomes equal to 0, which means the whole function would be undefined. So if we want to write it in interval notation, we can say negative infinity up to negative 2/3 union with negative 2/3 to 0 union with 0 to infinity. So that is the domain of this particular function. All right, let's take a look at the very last example. We have f of x equals 4x minus 5 divided by x squared plus 8x plus 12. So once again, if the denominator is equal to 0, then this whole function is undefined. So that's not allowed. So we need to figure out what values of x, when they're plugged in here, make this denominator equal to 0. So what we can do is we can factor this polynomial on the bottom. And the way that we do that is we say, what numbers multiply to 12 and add to 8? Well, that would be 6 and 2. So we could rewrite this as x plus 6, x plus 2, and that may not equal 0. So we can pretty clearly see here that if x is a negative 6, or if x is negative 2, that would cause this left-hand side of the equation to be 0. So we would say x is not allowed to equal negative 6 and x is not allowed to equal negative 2, because when we plug either of those numbers into this polynomial on the bottom, on the denominator of our original function, it would be equal to 0, which would make the whole thing undefined. So if we want to write that in interval notation, we could write negative infinity to negative 6 union with negative 6 to negative 2 union negative 2 to infinity. And that represents the domain of this particular function. Thanks for watching, guys.